All right, here's a good question. It's asking you, and we'll do a little bit more than what they say, but initially it says calculate how many moles of the indicated ion are present in each one of the following solutions. So let's take, we do a couple of them maybe. So let's do that first one. It says how many moles of sodium ions are there in a liter of 2.51 molar solution of sodium sulfate? Okay, so there's this number 2 right there that sort of gives me a clue on what I need to do. But first, let's start with writing a dissociation equation. So if I have sodium sulfate, and typically that comes in I think it comes in a bottle that's a solid, and if you put it in water, then what happens is it breaks apart into the ions. So you have sodium ions, and you'll have sulfate ions. And you can tell what these charges are just looking at your periodic table or that table of ions that's posted in Canvas. Now, right now this isn't balanced, and you can sort of see it's not balanced because there's a 2 minus here and there's a 1 plus there. And the charges need to balance in these dissociation equations. Also, there's 2 sodiums on this left side, so I need to put a 2 in front of the sodium. So that balances my sodium. It also balances the charges. Okay, so let's look at concentration first, then we'll look at moles, what they have. So here they say I have a 0.251 molar solution of sodium sulfate. So if I look at the equation, or this balanced dissociation equation, the numbers in front of each of the compounds or ions indicate how many of those things there are, how many moles of things there are. And actually you can refer to it as concentration too. So if there's one of these, that produces 2 sodiums and 1 sulfate. So if I have 0.251, and I can write out an equation to help me solve that. I can say I have 0.251 molar of sodium sulfate. So I can multiply by a conversion factor that'll determine how many moles of sodium I have. And that's what we're looking for. Actually, what the concentration is. We'll figure out moles in a second. And so I'd have 2 molar, looking at the moles, I'd have 2 of the sodium ions for every 1 of the sodium sulfate. So I can cancel the sodium sulfate out, and all I have to basically do is multiply that by 2. So I think that'll come out to 0.502 molar. So if I'm just looking at concentration, I can say that's the concentration of the sodium ions. Now, if they want to know how many moles there are, then I can use the formula. Moles is equal to mass over molar mass. I guess I can't use that one because I don't have a mass and I don't have a moles, so I don't have that one. Okay, we won't use that one. How about this one? C equals N over V. I have a concentration. Yeah, that's right here. And I have a volume. That's right there. So I can determine the moles. So moles, from that formula, I can manipulate it to be moles is equal to concentration times volume. The concentration of my sodium ions is 0.502 moles per liter. And my volume is 1 liter. So the liters cancel. I wind up with moles. 0.502 times 1 is just going to give me 0.502 moles. So that's how many moles of the sodium ions that I have. Let me just try maybe one more. Let's do the next one, B. So if I'm doing B, they're looking for how many chloride ions there are in 5.50 liters of a 0.1 molar solution of iron chloride. I'm going to do this one slightly different. Either way of doing this is fine. If you're using your ratios, you're all good. So what I'm going to do is I'm going to figure out how many moles of iron chloride I have, and then from that figure out how many moles of the chloride ions I have. Okay, first let's write a dissociation equation. So I'm starting with iron chloride. So FeCl3. If I dump that in water, and it's not reacting with the water, it's just dissociating in the water. Okay, so this will separate into iron 3 plus ions and chloride ions. Okay, and to balance things, I need, yeah, that's right. I was going to say 3 of these, but I don't need 3 of those. I need 3 of these, right? I need 1 of those and 1 of those. So if I have 1 iron chloride molecule, when it dissociates, it gives me 1 molecule of iron 3 plus and 3 molecules of chloride ions. But you can also refer to those as moles. So 1 mole of that gives 1 mole of that and 3 moles of chloride ions. So let's right off the bat, rather than look at concentration, which you can do, but let's look at moles first. So let's figure out how many moles I have. So moles are equal to C times V, and they gave me the concentration of 0.10 moles per liter, and they gave me a volume of 5.50 liters. So the liters cancel. When I times this, I get 0.550 moles. So that's how many moles of iron chloride I have. I'm just going to sort of write it right below there. So it'll be 0.550 moles of iron 3 chloride. And then if I look at my ratio proportion, since this is 1 and this is 1, it means I'll have 0.550 moles of iron 3 plus ions. And it'll mean that I have 3 times that. So it'll be, I think, 1.65, if I multiply that right, moles of chloride ions. Whatever 0.550 times 3 is. That's 15/116. And 3 decimal places. Yeah, that's right. For sig figs, I should have 3 sig figs. Looks like I have 3 done. Okay, so hopefully that helps you out in determining ion concentrations in a solution.